Hello everyone, myself Diksha Gupta from MCA 5th Sem IPS TABB. Today I am going to solve my first internal test paper set A, and here's the question first, which says find the cube root of 12 using Newton-Raphson method, correct up to 4 places of decimal. So we are going to start it. We can write x cube is equals to 12 and x cube minus 12 is equals to 0. We and we will find the differentiation of x cube minus 12, which comes out to be 3x square. We know that the formula of differentiation is nx to the power n minus 1. So we find the differentiation as 3x square here. We know the iterative formula of Newton-Raphson method is xi plus 1 equals to xi minus fxi upon my f dash xi. Uh, we know that the cube root of 8 is equals to 2 and the cube root of 27 is 3. So we know that our result or roots must lie between the 2 and 3. Let's suppose the value of x0 as 2.5, and now we are going to find the values. Uh, Now we are going to find the values for 12. For in first iteration we I equals to 0. In first iteration where I equals to 0, we find the x1, which comes out to be 2.3067. For second iteration we x2 will be comes out 2.2894. For third iteration, x3 comes out to be 2.2894. Hence, the cube root of a 12 is 2.2894. Newton-Raphson method is the best way to for finding the cube roots compared to other methods. Uh, this is our first question. Now moving to the next question, question second, which says write an algorithm for finding square root of 12 using fixed point iteration method. In this algorithm, in first step we used to read x0, e and n, where x0 is the initial value, e is the precision value, and n is the total number of iteration to be allowed for convergence. In second step, we used to initialize g of x0 in x1. In third step, we used to initialize for loop which is start from 1 up to n is number of iteration and incremented by 1. In this, we used to assign x1 to x0 as we know that our x1 is contained g of x0, so ultimately we are assigning g of x naught in x naught, g of x0 in x0. Now again we are going to assign g of x0, means we already know that our x0 contain g of x0, or and again we are going to assign g of x0 in x1, means we are assigning g of x0 in x1, and we are going to check this equation. If the equation, if this condition is less than e is a precision value. If it becomes true, then we go to the step number, then we go to the step number 9 and says that we get our convergence root I and xi, and our algorithm will be stopped here. If this condition is false and our for loop is iterate n times, means we do not get our convergent root, then we move to the step 8 and say step 7 and say we do not get our convergence root x0 and x1, and we will stop our algorithm here. So this is our algorithm, a fixed point iteration algorithm for finding the square root. So now moving to the next question, third question, which says give the output of a Gauss-Jordan algorithm for this matrices. First, we understand what is a Gauss-Jordan algorithm. Gauss-Jordan algorithm is used to solve the system of simultaneous equation. In this, we have to rearrange. In this, we used to write the coefficient of a equation in the form of matrices, in which this column will represent in matrices. These four columns means this column represents the coefficient of the equation, and the last column means this column represents the discrete numbers. So what we have to do in the Gauss-Jordan algorithm, we have to make all the elements zero which are below or up at the diagonal. Means we have to make all the elements which are this below or up at the this line. So we are going to apply the following operation for making it. We have to make R2, R3 and R4 element as 0. So what we are going to do, we will going to take the help of R1, means we are going to take the help of row 1. So what we are going to do, we used to in we have to make changes in R2. So we are going to R2 minus R1 multiply with minus 6 and divided by 10. So By applying this following operation on these matrices, we get the following output, in which we can see that the elements which are below the diagonal are become 0. Now we have to make all the remaining elements 0, which below or upper the diagonal, which is below or upper the diagonal. So we are going to apply same rule again. By applying this following operation, as you can see, we get at this matrices, we can see that we are very close to our answer. And again, by doing the same thing again and again, we have to repeat this step again and again until we get our final matrices, means this matrices, in which we can see that the elements which are below this diagonal and the elements which are upper the diagonals are 0, means we get our values, or we get our values means we get 10x1 equals to 49.99, which comes out to be 5 approximately, x2 as 4 and x3 as minus 7 and x4 as 1. Hence we get our values of x1, x2 and x3 and x4. So this is our Gauss Jordan algorithm. Thank you for watching the video.